Hello, ladies. Okay, as you were absent today, I'm going to quickly explain what we did. So instead of doing the lab practice as planned, because as many of you were absent, we decided to work on solubility curves. You previously had a look of these curves in the resources that you explored last week. So today we were practicing with exercises based on these graphs. So if you remember, we have these graphs to represent how the temperature affects the solubility of solids. As temperature increases, usually the solubility of solids increases. So we have this line. Every compound is going to have a specific line, a specific trend, and then everything that is going to be below that line is going to correspond to unsaturated solutions. Anything above, supersaturated solutions, and everything on the line is telling me what is the maximum amount of the compound that can be added at certain temperature. So this is a very common graph that we can have. So, and this is the type of questions that we usually answer from them. So for example, in here, if 60 grams are added of potassium chloride at 70 degrees, the idea here is that you classify the solution as supersaturated, saturated, or unsaturated. So in this case, what we need to do is first find the compound that we are interested in. So in this case, we need to focus in the formula. The formula for this one is KCl, potassium chloride. So we focus in that line here in the graph. So either way, you look for the grams on the y-axis or you look for the temperature in x-axis. Up to you, whatever you prefer. So I usually look first at the temperature. So if it's 70 degrees is right here. And then I go all the way up until I find the 60 grams. So 60 grams is right here. Okay, so if we go back to where the line is, KCl is right here. The maximum amount that I can add at 70 degrees is around 48.9, but it's a little bit less than 50. So if I add 60, I am adding too much. This is going to be a supersaturated solution. I am adding more than it can actually hold that temperature. Okay, so this will be classified as a supersaturated solution, the first one. If we go to the next one, exactly the same thing. We find the line. In this case is potassium chlorate, KClO3, right here. We look for the temperature, 60 degrees, right here. We look for the grams, 10 grams. So this is the reference point that the exercise is telling me. At 60 degrees, I am adding 10 grams, which is not enough to get a saturated solution. If I want to get a saturated solution at 60 degrees, I will need to add around 22, 23 grams of potassium chloride. So if I am adding only 10, that's going to be an unsaturated solution. So if I were to classify that one, that will be unsaturated. Okay, so this one is unsaturated. I'm just going to write an U and N. This was supersaturated because that was too much. So double S, supersaturated, unsaturated. Next one is sodium nitrate. So it's the line up here. And the same exercise. So in this case, 10 degrees, each in here, which is in here. And then I go all the way up to 80, which is right on the line. So this solution is going to be saturated. 80 grams is the exact amount that we can add in order to get a saturated solution at 10 Celsius. Okay, and that's it. That's one of the most common questions. Another one here, which is the most soluble compound at 10 degrees. So we just go to the temperature, 10 degrees, and find the compound that we can add the most amount of solid. So for example, this first line that we find in here, KClO3, we can only add around 5 grams. So that's very insoluble at 10 degrees. As we move up, we are going to find that the solubility increases. Calcium chloride, for example, I can add almost 65 grams of calcium chloride at 10 degrees. And in the most soluble compound in this case is going to be sodium nitrate, because I can add 80 grams compared to the opposite, which is 5 grams. So the most soluble compound is sodium nitrate. And the compound with the lowest solubility, sorry, this is cut, but it says so lowest solubility. This presentation is in Schoology if you need it. So the lowest solubility at 50. So once again, I go to 50, and the first line that I find is going to correspond to the less soluble compound, to the least soluble compound, because I can only add around 2 grams of cesium sulfate. While for the others, for example, potassium chloride, if you notice, it increased a lot as we move into the temperature. At 50 degrees, I can already add 18 or 19 grams. And as we go up, there are even some compounds that we can no longer see in the graph because the solubility is very, very high. Okay, that's pretty much what you need to do. So in your workshop, you're going to find similar questions. Another type of questions that are probably not here, but are also similar to solve and hope you don't have any trouble. For example, cases in this one, in the supersaturated solution. A question might tell you how many grams are not dissolved. So we go to our reference point once again, 70 degrees. Potassium chloride was the one that we underlining here. So the maximum amount that I can add is 48, more or less 49 if you want, and I am adding 60. So how much is not dissolved? I just need to subtract. If I am adding 60 and the maximum amount that I can add is 48 or 49, up to you what number you choose, then you subtract, and the difference will be the amount of solid that is not going to be dissolved. Another type of question, if you notice here in the graph, we have 100 grams of water. A question might ask you, what if then instead of 100 grams, you have 200 grams of water, or 300 grams of water, or 50 grams of water? So you will have to think of what's going to happen with the solubility. So if I double the amount, let's keep on using the same exercise that we have as reference, potassium chloride. If we have the same compound at the same temperature, 70 degrees, I can add 48 grams. But what if I double the amount of water? That would also allow me to double the amount of solute. So instead of having 100 grams of the graph says in here, if instead of having 100 grams of water, as the graph is showing in here, if I have 200 grams, it will allow me to dissolve double the amount of it. Okay, I think that's pretty much the type of questions that you might find. If you find another one, think about it and try to solve it, because they're not difficult. They are basically based on the same principles, being able to classify solutions as supersaturated, saturated, according to the information in the graph. Okay, let me know if you have any questions. Please submit it. You have 3 days to catch up, so Monday, Tuesday, Wednesday. Then Wednesday will be the deadline at 3 p.m. in the afternoon. Okay, let me know if you have any questions. Bye.